So let's take a look at question 13. So if we want to graph this, you want to follow the 7 steps that I have listed. So the first thing we need to do is get our function into factored form. So I noticed that on top, both pieces are divisible by 3x. So let's do that. Always look for a greatest common factor. Now the bottom is factorable because it can be broken up into x minus 1 and x minus 4. Okay, so we've done step 1. Step 2 is to look for holes. If any factor on top matches any factor on the bottom, that is a hole. So there is a hole when x minus 4 equals 0 or at 4. Now, we are going to cross out that factor, and for the rest of the problem, we are going to use 3x over x minus 1. So that's one nice thing about a hole. We'll address it when we draw the graph. From now on, we get to use that nicer version of our function. The next thing we look for are vertical asymptotes. Now remember, that is where any leftover factors equal 0 from the bottom. So we're looking for where the bottom equals 0 of that reduced form. So that would be when x minus 1 equals 0 or at 1. So let's put that on our graph paper. Okay, so now for the domain, we need to skip any of the zeros of the denominator, which will be the holes and the vertical asymptotes. So these 3 things go together. So think about on the number line, the first thing we're going to get to, going from left to right, is a vertical asymptote at 1, so we're going to skip that. The next thing we're going to get to is a hole at 4. We don't want to fall into the hole, so we're going to keep on going. So this tells us some interesting things. So there's our vertical asymptote, there's our hole, and what that told us is that our graph will be in 3 pieces. These pieces are going to be connected. There's just going to be a little hole in the graph, and we'll take care of that. Next, let's talk about the horizontal asymptote. In the first part, we talked about the fact that if our degree in our denominator is higher than the degree in the numerator, your horizontal asymptote is always going to 0. Here, our degree on top is 2, our degree on the bottom is 2. When that's the case, we are going to use the coefficients. So our horizontal asymptote, when the top power and the bottom power match, the degrees match for the top and bottom, just use your lead term coefficients. So that's going to be 3 over 1 or 3. Now let's put that on. Okay, now let's find our intercepts. Again, we're going to be using this simplified version here, this 3x over x minus 1 to complete the problem. So our intercepts, first our y-intercept, if I plug in 0, I get 0 over negative 1, which is 0. So I hit 0, 0. If I set the top equal to 0, I also get 0. So if you get 0 as your y-intercept, it is also one of the x-intercepts. You might have more, but it is definitely one. So the only place I ever hit this line is at 0, 0. The only place I ever hit this line is also at 0, 0. Okay, so now we need a graph. Now, for the graph, you must plug the whole value of 4 into the simplified version, so we know where to put the whole. So at 4, that would be 12 over 3, which is 4. So at 4, I have a hole at 4. So put an obvious hole in the graph at 4. But that tells me my pieces live in here. Now let's just check. Let's plug in 5. If you plug in 5, you get 15 over 4. And 15 over 4 is 3.75. So we can see we have a piece going like this. Okay. Now you should kind of expect that we're going to have a piece that goes here. And if you were to plug in some points, you would find, like if you plugged in -2, you would get -6 over -3 or -2. Or I'm sorry, that would be a +2. I didn't really go quite as steep as I should have. But it looks something like that. Okay, so you can plug in lots of points, but definitely you want to do the 7 steps that you see there. So we have that 5-6A homework, so you should have enough information to find that. So let's look at this graph. So the first thing we're going to do is we are going to get our function into factored form. The top factors to be x minus 2 and x minus 2. The bottom factors, if you first factor out an x, well, we can factor out an x squared actually. Let's do that. And you're left with x minus 5. There we go. Now, it is in factored form. We can see that there are no factors on the top that match any factor on the bottom, so there are none for the wholes. The vertical asymptotes occur when the bottom equals 0. So that's where x squared equals 0 or x minus 5 equals 0. So that's going to be at 0 and at 5. So let's put those on there. Now what that tells me is that my graph is separated into 3 pieces. So there's a piece that's less than 0, a piece between 0 and 5, and a piece after 5. So let's write our domain that way. We're going to get up to 0. We're going to have to jump across that asymptote. Then we'll get to 5. We'll have to jump across that asymptote, and we can keep going. Now, what is our horizontal asymptote? Well, our horizontal asymptote is 0 because our higher power is in the bottom. Remember, if the bottom is higher than the top, the degree, we always head to 0 on the ends. So let's make this end head to 0 and this end. Now you'll notice I didn't put a little thing here because of the fact that if you have some separation here, this piece is allowed to go through there. It is allowed to touch that, so that might happen. Okay, let's talk about our x-intercepts and our y-intercepts. First, let's do our y-intercept. If I plug in 0, I get 4 over 0, which is undefined. So there are no y-intercepts. I'm sorry, the x-intercepts is where the top equals 0. Now we only have one factor at 2. We should notice that we should have a bounce at 2. So we do have an x-intercept at 2. There's no y-intercepts. That's what there is. And I'm so sorry, I'm mixing all that up. So to figure out where the pieces go, it's going to bounce. So it's either going to bounce like that, or it could bounce like that. We got to figure out which. So let's plug in 1, and let's plug in 3. If you plug in 1, you get 1 over -4, so -1/4. If you plug in 3, you're going to get 9 minus 12 plus 4. 9 minus 12 plus 4 is -1. And then 27 minus 45 is -18. And so that's 1/18. So we know we're down here. Now I need some points over here. So let's plug in 6 and 7. If you plug in 6, you get 16 on the top. You get 36 on the bottom. And 16 over 36 is about 0.4. So that does tell me that we are up here. Now let's see where this piece is living. Are we living up here or down there? So now I'm going to plug in -3. You can really plug in anything. Okay, if you plug in -3, you get 25 over 25 over 9 times -8, which is about, I'm just going to give you the decimal. It's about -0.3. So at -3, I'm about -0.3. So that tells me that piece is living here. Okay? And then, of course, you can always check these in Desmos because they're very strange. So it's not a bad idea to throw them into Desmos. So that should be a lot of information you need to find the graphs for those problems. And then we'll practice some other ones later on. I had some questions about the 5-5 homework number 66. So let's do that together. Now remember, a function who has real roots or zeros that's kind of the template you want to use, okay? So first off, we have 3 of them. So that's going to be x minus a -1, x minus a 1, and x minus a 3. Now you'll notice that I put this little a. This is like a little placeholder for my front coefficient, and that's what this tells me. So the 2, 4 says that if I plug in 2 for x, my f of x, or my y value, is 4. So now for all the x's, let's put a 2. For the y value, let's put a 4, and that should give us our a value. So if I put in a 2 for this first one, 2 plus 1 is 3. 2 minus 1 is 1. 2 minus 3 is -1. And then I'm just going to combine those and divide by -3. So I found my a value. So that's all you have to do is we're going to take and we're going to put our a value back in, and then we're done. So our a value is -4/3 times x plus 1 times x minus 1 times x minus 3. Now, if you did want, that is a polynomial if you were to multiply it all out. I do not need it to be multiplied out. And that is one like that, okay? So there you go. Thanks so much. Have a great day.